Okay, everybody. I just got a message that my facilitator lost their speaker or their mic, so I'm just going to get started. You're in the right place if you are interested in learning about automating sex offender no-live zones. So this presentation will cover the technical approach to automating no-live zones for sexual offenders, which are locations where sex offenders are prohibited from living. During the presentation, I will provide an introduction to the model builder environment, and we'll cover some basic programming concepts within the Python scripting language. In addition, I will also describe how tying these technologies together is possible to fully automate the creation of these no-live zones on a schedule to accommodate the ever-changing state of our data inputs. So hello, everyone. Thank you for attending my presentation. My name is Quay Trimble. I've been working for the city and county of Durham for the last 3 years. My prior work experience involved time working in the private and academic sectors, but working in local government has been the most fulfilling experience of them all. I received a BA in geography and a Master of GIS from Penn State University and earned my GISP in 2018. I'm also a father of one rambunctious 9-year-old boy. I enjoy exploring remote outdoor locations, and I try my hardest to live a low tech session outside of work. So that's enough about me. Let's get started with the presentation. So several years ago, Samantha Jackson, a Durham County deputy from the sex offender registration unit, contacted me about making updates to some data sets that her unit relies on. This was only a few months after I began working in Durham, so I needed to wrap my head around, why this data was important. The sex offender registration unit is essential to the safety and security of Durham County families. Deputies assigned to this unit monitor registered sex offenders in Durham County. They conduct investigations and apprehend offenders in violation of the conditions of the registry. So as you can imagine, deputies in this unit rely on accurate and up-to-date information so they can optimally perform their job duties, which I'm sure we can all agree is an important component in helping to keep our community safe. So this got me thinking about the possibilities of creating a system that is able to automate the refreshing of these particular data sets. And we'll get into the weeds regarding this, but first let's learn more about this registry. The North Carolina Sex Offender and Public Protection Registration Programs are laws outlined in the North Carolina General Statutes, which are enacted by our legislators that make up the North Carolina General Assembly. The General Statute states, among many other things, under North Carolina law, certain persons who have been convicted of a sex offense or an offense against a minor are required to establish and maintain registration in compliance with the North Carolina Sex Offender and Public Protection Registration Programs. The general statute also details restricted activities for offenders who are listed on the registry. One of these restricted activities prohibits the offender from being on the premises or knowingly residing within 1,000 feet of the property on which any public or non-public school is located, excluding colleges or universities and homeschool locations, within 1,000 feet of the property on which any child care facility is located, and within 300 feet of any place intended primarily for the use, care, or supervision of minors. The general statute is very clear about what restrictions apply to the sexual offender, and with the help of Ms. Jackson, through an initial inventory of our in-house data, these were our findings. So this is just an overview of the various data sets that would be involved in the analysis. And we have a very good relationship with Durham Public Schools. We meet with them regularly and ensure that our data reflects the actual situation on the ground. Our non-public schools are managed by the Durham County Sheriff's Office. Child care facilities are also managed by the Durham County Sheriff's Office. We do have a part-time GIS analyst within our Parks and Recreation departments. So our parks are reflect situation on the ground and managed. Our parcel boundaries are managed by the Durham County Tax Administration Department. And the last two things that I've listed here are primarily used for geocoding, which I'll cover during the last portion of the presentation. But we do have an address coordinator who manages our active addresses, and our street center lines are managed by Public Works GIS division. So now that we have defined the problem and have details outlined by the North Carolina Sex Offender and Public Protection Registration Program, and we have identified the managed data sets, but I was also interested in exploring if the analysis process could be automated so that the Sheriff's Office would always see the latest output. Many GIS data sets are dynamic, changing in subtle and discernible ways. Every single data set that was identified in the earlier slide changes on a regular schedule or as needed. But the point to this is that the data changes, so the analysis needs to be done over and over again. But why automate? So when we are deriving new products from dynamic data sets, the derived products need to be updated, and not just once, but as we go. As source data is updated, derived data sets need to be updated as well. Even if using something like Model Builder helps you automate the analysis process, the process of deriving new data sets, the model still needs a click of the mouse to run. And since my number of day-to-day responsibilities isn't shrinking, automation allows me to set it and forget it, or at least to devote less time to the process by developing an automation system. Okay, so we've defined the problem. We have identified the data that will be involved and why it's important to automate. So here I'm providing an overview of the technology that makes up the automation system. This likely reflects what architecture many of you have implemented. Nothing's really jumping out here as a custom component or something that wouldn't be common in an enterprise GIS system. But one thing I wanted to point out is, since there is a significant difference in the cost, is that the geoprocessing tools that are utilized in this system are available at the basic license level in your desktop environment. And this is the case for either ArcMap or ArcGIS Pro. It is also worth mentioning that an enterprise database system is unnecessary to be used for this system to work, but you would need an ArcGIS Online account, and you would need to use the ArcGIS API for Python to automate overriding the derived data sets, but only if you wish to create a web mapping resource with your output. So as I mentioned prior, there are no advanced geospatial analysis happening here. It's just basic selections and buffers. And I really wanted to drive that point home by providing this diagram. Essentially, 2 steps to get to your output. You start with your data, You may need to create some subsets through either attribute or location selections. You apply a geographic criteria, which has been outlined for us: 1,000 feet for childcare facilities, 1,000 feet for schools, 300 feet for parks, and poof, there you have your no-live zones. So it seems very simplistic. And I wanted to show you this slide before I show you the model, because the model can look a little more complex. So I'm going to try and jump into a live demonstration here, just so I can interact a bit more with the model as I'm describing it to you. Okay, so this is the ArcJS Pro interface, and this is the model that I built. I apologize that it does look very small to you, I'm sure, but I'll try to zoom in as I'm describing the separate components of the model. At this scale, you see a lot of colors and shapes, so just a brief overview of what these things are. The circles that you see here on the screen are representing your data input and outputs. Data that is blue is your input, data that is green is your output, but can also be used as your inputs. And then the yellow rectangles are your geoprocessing tools. I'm going to try to zoom in a little bit. So many of the data sets that I'm using contain multiple facility types that fall under a particular theme. One such data set is named emergency mitigation facilities. And this data set contains senior care facilities, child care facilities, and pharmacies. I bring this up to you so you understand that in my model, I have to take some additional steps to filter the data down. And then I can move on to do my additional selections and buffers. So you see my selections are being done by first creating, or first using the make feature layer tool. And once I have this make feature layer applied to my input data sets, I can make these selections to the data sets, and they'll be held in memory during the time that the model is being ran. The next major step is the spatial selection. So this is used to select the parcels where schools and child care facilities are located. So child care facilities and schools exist in our environment as points. This step is not needed for parks, since the park takes up the entire parcel. Then once the parcels are selected for each facility type, a buffer is applied. So here we're nearing the end of this model now. Here's the buffer tool. So this is the buffer tool is how we apply the criteria that was defined in the registry. So again, the 1,000-foot buffer for schools and childcare facilities, and a 300-foot buffer for parks. Following this step, the buffer outputs are then merged and dissolved, because our no-live zones are used purely for illustrative purposes at this time. The final step involves using the truncate table command to remove all records from the existing data. At this time, they'd be outdated because we've assumed that there are some changes to the input data. So using the truncate table command is going to remove all records from the existing data set. And then we would use the append tool to actually add the new records into the existing data set. So since the data set is published as a web service, working with the same feature class is important. Otherwise, you will run into database locks. So if you are looking to delete an existing feature data set, and add a new one if anything in that database has been published as a web service. You probably will run into some issues. So using the truncate table and append is the way around that. So I just wanted to kind of quickly demonstrate how you would add data and connect it to a geoprocessing tool. So here you have your database connection. I'm just going to throw this into the model. This is the emergency mitigation facilities feature class. And here's the make feature layer. So you can just easily drag and drop the tools and the data sets from your catalog and geoprocessing panes. And then it's just a matter of clicking and dragging to connect your data to the geoprocessing tool. And then it gives you some options here. So if I just say it's an input, this is a good sign. If those gray shapes get some sort of color applied to them, then you're in good shape. Once your model is done, you can use the validate tool and run it. I'm not going to run it because it does take a little bit of time. So that covers creating the model. Let's learn how to run the model on a schedule. So the images on this slide illustrate the property dialogues for the toolbox and the tool or the model. The information shown here is needed to reference the resources from within the ArcPy module in the Python scripting language. Hopefully showing you this saves you some time. It was a little confusing to me, and it wasn't clear what the purpose of the label and the alias were for the toolbox properties. So to keep things simple, I used the same name for the name, label, and in the case of a toolbox property, the alias. I would advise you to stay away from special characters and spaces, which are just not a good idea when you're programming. Okay, so here's the Python script that runs the model. In summary, it just takes a few lines of code to import the toolbox and then to call the model. The first few lines of this script are calling the specific modules that expose the necessary functionality from within Python that I'm going to need. ArcPy is the only required module, but I like to write some messages to a log that are generated from the script and that may be useful for troubleshooting. So I'm using the logging module as well. I'm also using the date time module, but that's primarily to give my log and some messaging in my log a date and time stamp. I feel like this is useful information in case I need to cross-reference date and times with other system events. So you can see at the top where I'm importing the modules. You see there's 5 lines of code there. Following the import of the modules that deal more with the logging aspect of things. And then the 2 required lines, which are highlighted here in cyan, using the import toolbox. I'm just defining the relative path to that toolbox. And then the next ArcPy function is where I'm actually calling the model. Following the format of model name underscore toolbox alias. And then I end the scripts with just the end time when the script has finished running. Okay, so I'm gonna blow through these next few slides, but it is important to look at these because it illustrates how to fully automate the analysis. So I'm using Task Scheduler to run the script, and this is a dialog from the Task Scheduler. On the General tab, you definitely want to provide a name and a description. You want to make sure under security options that you're running the script using an account who has the correct level of permissions. The next tab would be the trigger tab, and this is just where you would actually schedule what time of day and how often you would like to run the script. And then I think this is probably the most important thing to take away is the action. What you're actually doing here is starting a program, which is the Python program. So you need to define where the Python executable lives on the system where you're going to be running the script. If you don't know where that is, you can fire up the Python interactive terminal, import the sys module, and execute or use the executable function, and it's going to return the path on your local system where the Python executable actually lives. And then the last thing is you need to specify the script name itself. That would be the argument that you're passing into the Python exe. Once you have all that configured, then your script will run on a schedule and your system will be fully automated. Some quick caveats and takeaways. So who are the data custodians? This is always a challenging thing to answer because we were relying on the sheriff's office to maintain or manage our childcare facilities and non-public schools. I felt that this wasn't feasible long-term, and we were looking for other data custodians. And we know that this data is managed or regulated, I should say, by the state. So I did identify that the Division of Child Development and Early Education does make childcare facilities available through the internet. So I am working on a script that would automate pulling that information down and processing it. I would like to identify a similar process for non-public schools. So if any of you can recommend a data source for that, I would appreciate it. So in using childcare facilities, we're given addresses. So geocoding is something that would be introduced into the process. With our current composite locators, I wasn't getting 100% match. So I introduced the ESRI Locator view. This did help me achieve 100% match in some of the cases where my locator wasn't accommodating locations or addresses was where we just didn't have an alias name set up for a road, mostly for state and local roads, that can contain both a route number and a local road name. A caveat to using ESRI Locator is that it does come at a cost, and you do need an ArcGIS Online account. I think it's about 40 credits per 1,000 geocodes, so it doesn't seem very expensive. And if you do have an account on ArcGIS Online, I believe that it comes with some credits. You can also purchase credits a la carte. And last thing, I just wanted to mention that data integrity is always important when we're managing information. Data sets need to follow some rules for completeness and logical consistency in order for us to have confidence in the information. So ideally, addresses would always be matched to the equivalent address point, but this is a difficult thing to QC. One aspect that could involve more automation is the use of Python or Arcade for proximity searches and feature updates to match to the address point. Okay, so I just wanted to give you a quick look at the end user product that was developed for the Sheriff's Office, and then I'll take questions. So again, this information is provided purely for illustrative purposes. The pink points that you see on the map are our childcare facility locations. The sort of blue-green points are schools, and then the green outlines are our parks, and the sort of pink buffer areas are the exclusionary zones or the no-live zones. You can see here is an example where we geocoded a childcare facility to a street center line. So there was no buffer applied to this location, but we still provide the point on the map with some, a measure tool just to give the sheriff's office a reference, and they can work off of that. So that's all I had for you today. I'm happy to take questions at this time.
Yeah, thanks, Quay. That was very interesting. I'm Brett Spivey, your fill-in moderator. Your actual moderator's computer just blew up, so nothing but like a little excitement here towards the end. If you do have any questions, please go ahead and make sure you throw them into the chat. We'll get those passed to you and try and knock these out. We do have a question from Rachel Smith, and her question is, what is the website for the child care facility from the state?
Yeah, so it wasn't anything that I was able to find through like a Google search, but I don't know if there was a way that I can maybe provide this in the chat window.
If you want to go ahead and shoot it to me in the chat, I'll relay that. And it's actually kind of a decent segue. If you want to contact, I work for the Center for Geographic Information and Analysis over in Raleigh. So if you want to reach out to us, I know there are some efforts going on to develop a comprehensive school data set that includes public and non-public schools. That's been a challenge and a use case that has come up quite frequently. So just be sure and reach out to us for that, and that will help us, with our business case and data development efforts here in the near term.
That sounds great. Thank you for that information.
Sure. Michelle says that the DHHS Division of Childhood Development and Early Education may be a source for some of the child care facility data. And we have a question.
Yeah, that's exactly where it comes from.
Okay. And then Aaron Lesh asked, what percentage of residential area is outside the no-live zone?
We haven't taken that no-live zone output and have done any further analysis with it. So I can't answer that, but that is an interesting question. I don't think that's something that we've looked at. I'm not sure. Yeah, it would just be interesting, but I'm sorry, I don't know the answer.
Yep. And we've got a couple more minutes. So if anybody has any more questions, go ahead. I'd like to ask one from a personal note. So have you found, or was it this particular project you did this, or is this a typical workflow that you do where you start off in Model Builder and then just call that from Python? Or do you develop a model in Model Builder and then port that to Python and run that Python script? I know some of this is I like apples, you like oranges type thing, but what's been your experience in terms of the most efficient and effective way to develop a script that may or may not run as a scheduled task?
Yeah, I think if you can achieve everything you need to in Model Builder, I think that is the way to go. And that way your Python script only has to, reference that model to run it. In a lot of cases, especially with what I'm doing in childcare facilities, there's some pre-processing that needs to happen outside of sort of the ArcPy environment. So I'm given, an XML file. So I need to sift through that XML file to, identify or isolate, the specific tags that I'm interested in. In that case, Model Builder would not be the preference. But anything that you would do within ArcGIS Pro or ArcMap, if you can achieve, that entire process within Model Builder, I think that is the most efficient way to go.
Okay, good. And thanks for that information. So it is 1 o'clock. So I want to let everybody have the opportunity to jump over to, I think it's the closing remarks that are coming up. And before you roll your eyes and let out a giant sigh, I've been promised that that's only going to take about 15 minutes. So I'd like to thank you again for the presentation. Please reach out to us, like I mentioned before, and I actually may be contacting you for something that I'm working on that's very similar. So thanks again, and everybody, we'll see you over at the closing remarks, and enjoy your weekend.
Thanks, everyone.